So we just learned how to name degrees of polynomials. Now a degree of a polynomial will determine how that polynomial behaves on a graph. It will determine the maximum number of turning points, and it will also talk to you a little bit about the end behavior of the graph, whether it goes up and down, down and down, up and up, whatever and up, okay? And this table below, this is going to help us learn about this a little bit, okay? Excuse me. So let's take a look at this particular example here. Can you see how this one, first of all, we have a power of 4, okay? And this ends, can you see how this ends up going up and up? Okay, that's what we call its end behavior. I'm going to put really big points on the turning points. 1, see how it takes a turn there? 2 and 3 turning points. Do you see them all? How it ready? It's going down and it turns, up and it turns, down and it turns. So you can see they labeled the 3 turning points. Here, here, and here. Now we're going to talk about the decreasing aspect together. A lot of students struggle with this. You should kind of be able to remember that when you talk about decreasing and increasing, you need to read the graph left to right. Okay? When you talk about increasing and decreasing, you need to read the graph left to right. So I'm going to talk about this and let's see how well you do. You ready? As I trace left to right, tell me what's happening. It's going down, it's going up, it's going down, it's going up. A lot of students want to tell me that this area right here is increasing, but if you read it left to right, it is going down. Okay, so it's very important that you read it left to right. Let's look at this one. Notice with the power of 2 that this particular graph has the end behavior of down, down. It has a single turning point right there. You should remember that's called the vertex. And let's talk about this left to right. You guys ready? Notice that this one is increasing, turning point, decreasing. Let's look at an x cubed. An x cubed, the end behavior on this particular example is down, up. There are absolutely no turning points because, let's go ahead and read, can you see as you read this left to right? Watch, ready? Read this left to right. It's going increasing, 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 increasing. Look how it's still increasing here. Okay, there's 0 turning points because it's always increasing. So sometimes it won't be a turning point. That's why up here, I made sure when I circled stuff, it's going to tell you the maximum number of turning points. And let's look at the last graph. This particular end behavior goes up and down. It has 1, 2 turning points. And if you read it left to right, you should tell me, follow the pen. It's decreasing. It hits a turning point. Increasing. It hits a turning point, decreasing. We'll talk a lot more about that in the upcoming examples. Okay. You can determine the end behavior of a polynomial function. You can determine the end behavior of a polynomial function from its degree and the degree of the leading term. Okay, so let's say that your leading term is positive and the exponent is even. Your graph's going to go up, up. Let's say your leading term is positive and it's odd. It's going to go down, down. I want to give you some examples of that, okay, and the negatives as well. If you have 4x to the 6th power, notice that 4 is positive, okay, and the exponent 6 6 is the exponent, 6 is even. You would go to this graph up here, and you would find positive, even, and the end behavior would be up, up on this example. Let's try negative 2x to the 5th. Okay, notice that negative 2 is negative, and 5 is odd. So the coefficient is negative, the exponent is odd, so we would go negative odd is up, down. We'll do one more and then we'll move on. Let's say that we have 3x squared. You should know that's a parabola, by the way. 3 is positive. 2 is even. So you do positive, even, up, up. Okay. Now a lot of students try to look at this, the coefficient, and say whether it's even or odd. The coefficient doesn't matter if it's even or odd. The coefficient only matters if it's positive or negative. In general, and that right there is a super important phrase. In general, the graph of a polynomial is going to take n-1 turns. So, if we have, here's your example of this paragraph. If you had 3x cubed plus x plus 1, you would tell me that the degree is 3 because of this exponent. That means that in general, or most likely, it's going to take, you ready? In general, it will most likely take 3 minus 1, 2 turns. I'll do that one more time. Let's say that you have a 2x to the 4th plus 4. Okay, just a general equation. On a graph, you should be able to tell me before you graph it that the degree is 4. Okay, so that it will most likely take, ready? It will most likely take 4 minus 1, or 3 turns. And we're going to play around with this on a calculator a little bit more, okay? Let's go to problem 2. Problem 2 is just going to describe the end behavior. So this chart up here is going to be very important for you. Okay, so always refer up to that chart.